Good afternoon. This is Justin Hogan. Today I'll be going over the hydration bot. The hydration bot is very conditional. A lot of its actions are based off of the actions of the isWater bot, which is our moisture detection bot. So the code here, which is linked in the description, has a lot of while loops that ultimately function based off how far the isWater bot is from the hydration bot. This bot has a total of effectively 2 actuators with 1 sensor. I kind of count these 2 DC motors in the back as one because each of these help drive the drone forward on the guide rail. This actuator here, another DC motor, is attached to a rotary valve, which upon activating releases some water through a spigot. We have the ultrasonic distance sensor, which measures the distance between the isWater bot ahead and the hydration bot. And then finally, we do have a IR LED. The way I'm going to demonstrate this is just by showing you different distances on this ultrasonic distance sensor here. So we'll go ahead and start the simulation. Right. So at this time, it says 7.9 inches. So this is essentially when you have the hydration bot and the isWater bot static and ready to move to the first moisture detection point. Currently, the IR flash is flashing. This is what the hydration bot uses to communicate to the moisture detection bot that it is ready to continue on after it is finished watering. At this time, the moisture detection bot is not looking for this signal, so it's completely irrelevant. So the isWater bot starts moving forward, so its distance exceeds 10 inches. It is now moving towards the first moisture detection point. So here we go. And at this point, I have delays of 1 second. I can fine tune this, but I found this to be good for the code to really work. So it waits 1 second and then starts the DC motors back here. The isWater bot then stops. And once the hydration bot stops, nothing happens. The moisture detection bot is simply just detecting the moisture in soil, and it's determining whether or not that area needs to be watered. Now let's kind of follow the first case here. Let's say that the moisture detection bot determines the soil needs water and moves forward 10 inches or less. Okay, so we're going to have it exceed the distance, and then shortly after, it's going to stop. At that time, my hydration bot is going to activate this DC motor to release water in the soil. We'd be approximately 10 inches forward, so we'd be about where the moisture detection bot detected low soil levels. Now you see that this IR flash is happening. It's actually a regular LED given the limitations of Tinkercad, but we do have some programming that we can implement if we want to try and have IR communication between the robots. But this is basically symbolizing that the hydration bot is signaling to isWater that it is finished watering and it's ready to continue on. Also for context, this DC motor activated for 5 seconds. We could fine tune that depending on how much water we feel needs to come out of the valve. Okay, so isWater received the communication that's ready to move to the next moisture detection point. So it's going to start going forward. Its distance exceeds 10 inches. It goes to the next moisture detection point. And at this point, its distance can be this way for as long as necessary or as short as necessary. It's not going to change how the hydration bot acts. So it's moving to the next hydration point, the next moisture detection point. It's now stopped. The hydration bot stops. And now it's ready to read whether or not the next movement is going to be equal to or less than 10 inches or greater than 10 inches. So let's explore the second case. Now the isWater bot moves forward. And instead of stopping within 10 inches of the last point, it continues on. It goes on for several seconds. And then it finally stops. You'll notice at this point, nothing happens because all exceeding 10 inches basically signaled to the hydration bot that nothing needs watered. We're just moving on to the next hydration point. So yeah, that's essentially how this thing works. You can do this in any order. You can have it move to a moisture detection point and then move to the next moisture detection point. The code is written to where it will only water if that specific sequence is achieved. And I basically did that by using if the travel distance is equal to or less than 10 inches at any point during this code, it will then act as if the bot is going to the next moisture detection point after watering. So yeah, that's ultimately the hydration bot in its full form.